Hi all, and welcome to episode 4.2 of The Process, which is a series about Elixir processes. This episode is about GenServer. We're going to put together everything we learned about call in the previous episode and talk about why GenServer.call is a little bit more than what you might expect just based off of its description as something which is a synchronous call and response from your GenServer. So in order to do this, what I've done is I have set up a couple of example GenServers. This is a sort of GenServer that you might see in some sort of example code. It's a pretty simple GenServer, and what it's going to do is it is going to store a value. In this case, it's going to be a count. So let's go ahead and see what that looks like. Okay, so when we call GenServer.start, it's going to return an OK tuple with the identity of the server. So let's go ahead and run that. And note that we started it with some value here, which is 1, right? This 1 will be passed into the init. Note that the init is run on the inside of the process. The start runs on the outside of the process. That's very important. When you're initializing and bootstrapping a GenServer, it's very important to think about what goes on the inside and what goes on the outside. And I'll get into examples about that in a future episode. Then the signature of init requests that you return an OK tuple containing the state of the GenServer. In this case, we're not going to do anything fancy. We're literally going to just keep the integer count so far in the state. We're going to have an increment function. It's important to know that this increment function is an external API function. So when we call this, we need to be calling this from the outside, which is why it takes server as a parameter, so it knows which server to be talking to. And then it's going to call GenServer.call with increment as our payload. We're going to implement handle call. It's important to note that this function runs on the inside of the GenServer. It's going to pattern match on our increment payload, and it's going to receive a from, and then it's going to take the count. It's going to reply with count plus 1 and store count plus 1 in itself. So this is a basic counter. And we can see that because if we run realCounter.increment, we're going to now have 2. And then if we run it again, we're going to have 3, and so on and so forth. In the last episode, we deconstructed the messages that are going back and forth in this process, in this sort of an interchange right here. And so what I've gone ahead and done is put that together into a single module. So let's take a quick look at this. In our fake GenServer, our start function is just going to spawn the running of this loop function, which will capture the count variable inside of it as the parameter that gets baton passed between each iteration of the loop. You're going to see at the end of the loop function, we're going to call back into loop, and that's going to effectively perform a tail call recursion, and that's how all GenServers work under the hood to a first approximation. There are some important exceptions. But in any case, the start function expects OK and a process ID, and luckily our spawn function will indeed return a process ID. The next function I implement is increment, because this kind of already takes care of start and init. It's important to note that increment is run on the outside of the GenServer, which is why it takes server as its parameter. We're going to assemble the message that we saw before, which was this magic gen call atom, with a second term that is the from, which is the PID of the process that is making the request, and some reference. This reference is going to be created using the makeRef built-in function, and our payload in this case is going to be increment. So we're going to manually pack this together. Note that GenServer.call does all of this for us. And then what we're going to do is we're going to block and wait until we receive the reply that we expect, which is a tuple consisting of the ref that we sent out in the beginning plus the reply. So we expect that this increment function will perform the increment. Then here in the handle call, what we're going to do is we're going to trap on the increment, and this is basically exactly the same as the handle call function from RealCounter. Finally, the loop function looks like this. We're going to block until we receive a message. And if that message is the magic gen call message, we're going to capture PID and the reference from the from piece and keep the payload. We're going to reassemble that as a handle call with payload at the front and the from in the second position and the data, which is our count, in the last position. Then if we responded with the reply and the new data, we're going to reissue that the message back to the caller, which we have identified with the PID, and then the message that we're going to send back is going to be the ref and reply, and then we're going to tail call back into ourselves. So let's see if this works. So we go ahead and start the fake gen server, and then we can run an increment on it, and it works. Now, here's the interesting thing. Just to prove to you that for real, we have actually implemented something that is basically the API for a real gen server. The next thing I'm going to do is I'm going to call using the RealCounter increment function, which does use the GenServer.call. And you can see it continued from where it was before. Can I do the opposite thing? So let's start up a new server. And then now I'm going to do fake gen server counter real server. And you can see that one works as well. So this is kind of a nice way to really show that we have actually gone and at least partially implemented the API for how you can talk to a gen server using the call mechanism. However, it's important to know that this is not the full story, and that's what we're going to go into next. Okay, the first corner case that we're going to investigate is what happens if we try to call a process that, for whatever reason, doesn't exist. So we can have a PID that corresponds to server, and that server might no longer be running for whatever reason. So let's go ahead and create a process that is no longer running. And in this case, the easiest way to do that is to spawn a function that just does something, or very little in this case, and immediately returns. This process that was spawned as specified by the variable dead is no longer alive. So process.alive, and that is not alive. Okay. So what happens if we take RealCounter, which is our real gen server, and attempt to increment a dead process? Well, we're going to get this exit. And actually what this would have done is whatever the calling process was that tried to make this call would have been shut down with an exit. In the case of the terminal, the console is a special case, and it knows about the exact type of exit that just happened, and is aware and traps those exits, and doesn't force you to reset because it incorrectly calling a dead gen server is a common enough occurrence that the console would put you in a real bad situation if it dropped all of its data when you made a bad GenServer call. But in any case, you can see that it tried to exit. And what, by contrast, happens if I try to do this with my fake GenServer? Well, nothing. We basically hang. And why is that happening? That's happening because we basically go to this send statement here. It tries to send it to a server, which is a dead process, and that goes out into ether, gets sent to dev null, and nothing ever happens. In our increment function, we block on this receive call, and when we block on this receive call, we're waiting for this reference and apply, and nothing comes back. So you can see that by crudely implementing a gen server, we've missed this really important corner case that the folks at who've been building OTP have really thought about. Okay, so how are we going to go ahead and implement a safety mechanism that is missing? All right, so what we're going to do is we are going to insert a check to make sure that the server is actually running. Pretty simple. This is unless the server process is alive, we're going to call process.exit itself with no proc. No proc is the special type of exit that the console is checking on, and it's associated with, among other things, attempting to call a gen server that doesn't exist. So let's see what happens now when we run this. So I'm going to go ahead and make a dead server. And then I'm going to fake GenServer counter dot increment dead. And now you can see here we got a very similar exit reason, which is that the process is not alive, or there is no process currently associated with the given name, possibly because its application isn't started. So there you go. That is the first of the corner cases that gen servers are designed to protect you from. Let's look at another one. Okay, the second corner case we're going to investigate is what happens if the gen server just never sends a response. So let's go ahead and implement that. In the case, and we're going to make this easy, we're going to implement this in the real counter case only. So remember from the previous video, we could also issue a no reply response from your handle call. And in this case, let's just not even bother changing the count. All right, so recompile. And then let's start a new real counter. Let's start a new real counter server. And what happens when we try to increment this? Well, it does block because it is patiently waiting for the response. But after 5 seconds, what you can see is we got this exit timeout that happened. What, however, would happen if I did this with the increment from fake gen server? Well, as you might expect, nothing, because we don't have any sort of timeout built into this receive. And because there's no timeout, built into this receive, we can block indefinitely. And that's not a good situation. We don't want the default GenServer to basically halt progress waiting for something that may never get back to you. It could have dropped your message in some sort of queue, or in some cases, yeah, sure, like it could be processing other things and just not ever getting back to you for a really long time, and maybe you had something better to do. But the most important thing that this does is it creates a back pressure. And so note who got crashed when this exit happened. It was the caller. So the interactive shell or whoever called it would have crashed. It's not the server. The server is still running, right? Because we still have this unless process alive. We know that server process is still running, but it's the caller that has to exit. And the reason why this is back pressure is because let's say you have 100 callers that are making a request on a poor GenServer that's trying to do a lot of work. Well, what's going to happen is, as it's occupying itself doing work on all of the other tasks that have been requested of it, some of the requesters that haven't had their stuff handled are going to time out and kill themselves, and that basically reduces the amount of pressure that the GenServer has to endure because the requesters are what are getting terminated. So, okay, so let's go ahead and kill this right now. And what we're going to do is we're going to implement a procedure that will allow us to time out. This is pretty easy. All we want to do is make an after clause. And so we can do 5,000, which is exactly what we would have had for the normal GenServer. That is the default timeout. You can specify a different timeout. And then we're just going to process that exit self with timeout. Okay, so let's give this a go. So we're going to counter. Oops, let's do this. And now we're going to attempt to do the increment that will never happen. And we can see that we also, like in the other one, exited with a timeout. Okay, so let's talk about the third corner case. The third corner case is going to be the situation where what if the GenServer itself winds up self-destructing in response to the call request, or possibly some other call request that some other process has made. Or maybe the GenServer got a call request and in response generated another call request to another GenServer, and that GenServer was overloaded, and so this GenServer exited. Well, first, one way to create a GenServer exit is to raise an exception. That's a pretty easy way to do it, but we'll also show you with process.exit. So I'm going to raise kaboom when we call this increment function. So let's handle this. We're going to start a server. And then we're going to attempt to increment it. And whoa, we see a whole bunch of errors, and basically what wound up happening was the kaboom from the GenServer caused the shell to itself exit with the notification that there was an exception that happened. So we're gonna have to start up another server, and let's see what happens when we try to increment with fake GenServer. So first of all, we did get the notification that the outside GenServer managed to crash. But interestingly enough, the calling GenServer exited with the reason timeout. That's not exactly correct. And in fact, what happened was we had to wait 5 seconds. But really, you should, as soon as that other process goes away, you should it's yourself instantaneously uh, throw an error or cause an issue. So let's take a look at how we're going to implement that. Okay, so in order to implement this, we're going to have to add in a slightly more complicated mechanism than what we've seen to date. And what this needs to take advantage of to get an instant notification that the gen server that you've called has perished, you need to use something called a process monitor. This is something that's built in to the Beam virtual machine, and if you want to think of one way to think about it is that there's a universal bus, a pub subsystem, if you will, where you can say, hey, I'm going to subscribe to notifications about whether or not this process is gone. And as soon as that process goes away, you receive a message, hey, this process has gone away, into your mailbox. So how do we do that? The thing that we need to do is we need to use the function process.monitor. So we are going to do that here right before we send the call, right? And it's going to also create a reference data type. We're going to call that monitor ref. Then the shape of the message that's going to wind up in our inbox looks a little bit unusual, but it looks like this. And you can find this in the Elixir documentations for the process.monitor function. It's got this all caps down atom, followed by the monitor reference, the atom process because we're monitoring a process, the server PID, and the reason, which is the reason why the process died. In this case, it's going to be the kaboom reason. And then, in response to this, what we're going to do is we're just going to exit ourselves with the same reason. Is this enough? No, it's not. And the reason why it's not enough is because we still have this monitor taken out. And if we succeeded, we have a problem that perhaps that other server, the gen server that we called, died for some other reason. We don't want to get these spurious down messages into our mailbox, even though we're not really checking for them. So the thing we need to do is we need to do a process.demonitor. And that'll basically unsubscribe us from this pub sub of notifications about this other process. Okay, so let's take a look and see this. And let's go ahead and start our real counter server, which has the kaboom. And now that we've done this, we can take our fake server, GenServer counter, and use the call mechanism to do this. And you can see the shell process now got the reason kaboom, which was forwarded from the process that it called. And that was instantaneous. We didn't have to wait for the timeout to expire to know that our process had gone away. Okay, so those are the three very important corner cases that GenServer's call mechanism takes care of for you. And I mean, you should be happy that you don't have to write all of this code every single time you want to make a GenServer call. And I think what's really interesting is that this is really one of the major strengths of the Beam ecosystem, and the Beam virtual machine gives you access to be able to instantaneously get feedback when something on the other side of your virtual machine, or possibly even across the cluster on another machine, happens. Pretty much very few other programming environments and programming frameworks will give you access to this level of knowledge about what's happening in your system. And GenServer.call, it should generally be your go-to whenever you are making any sort of an interface with a GenServer. If for no other reason than it gives you back pressure control. Even if you are replying just an OK, you should use a GenServer call mechanism instead of, say, using cast, which we're going to talk about in the next episode. So the reason why you want to do that is because if too many things are making requests against the GenServer, you want to slow that process down. And if for some reason you have a mechanism to keep growing the number of things that are making a request, eventually you could very easily overload your GenServer with none of the upstream stuff being the wiser. Whereas if you have a same process same mechanism that's growing the number of things that are making requests to GenServer and they're using call, eventually they'll start calling themselves if too many requests are being made. Okay, so that was pretty long, but I think this is an extremely important set of topics to talk about. I think that GenServer.call is the most important interface for the GenServer for the reasons that I talked about. And I hope after watching this video, you have learned something and maybe you agree with me that GenServer.call is incredibly important. I'll see you next time.